Today we're going to look at a magic square. I found this magic square in a museum in Xian, China. It's a 13th century artifact that was found buried at the corner of a palace. It was designed to ward off evil spirits. One of the interesting things about it is it's using Hindu Arabic numerals rather than Chinese numerals. So to solve this magic square, to understand what these numbers are, we can look at it and say, I think I see a 0 there, there's another 0, and that might be a 1 and a 1 and a 1 and so on. And I can continue to look around and say, I see something that looks like a 9 here, I think I see something that looks like a 4 here, I see something that looks like a 5 here. But rather than just guessing, I want to actually puzzle it out. Searching around on Wikipedia, I was able to find some examples of older styles of Hindu Arabic numerals. And not one of these things exactly fits the square, but some of them are close. To puzzle it out, I'm going to make a list. I'm going to list all the numbers 1 through 36, and I'm going to count the numbers of digits that appear. And I see there's 3 zeros, and there's 14 ones, and there's 14 twos, and there's all the way up through there's 3 nines. Also noting that the numbers that have zeros in them all have a tens digit, we can be fairly confident that this is in fact the 0 digit. Next, I'm going to look for the most common digits. 1s and 2s seem to be the most common, and I'm going to look at the magic square to see if I can figure out which is which. So there are 14 symbols for 1 and 14 symbols for 2. I'm going to start out assuming that this is the 1. That's an assumption, but I'm going to test it in the end, because if my magic square doesn't work out, then I know I went the wrong direction. This other symbol doesn't really look like a 2 at all, except if you turn it sort of sideways, it kind of does. We can assume that must be the 2 because there are again 14 of them on the screen, if we allow that this one here is a 2. Again, we'll find out if we're wrong. So we have 0, 1, and 2. Now I'm looking around for what's next most common, and this is the symbol that's the next most common, and in fact there are 11 of them, so that must be our 3 numeral. I think we've now identified 4 of the numerals correctly. I'm going to replace them on the magic square just so that we can see where we are and what's going on. Now, remembering this is a magic square, the numbers from 1 through 36 add up to 666. That's for all of the rows or all of the columns. So 1/6 of that is 111. I'm looking at these rows, scanning across, seeing if there's any simple rows that only have one variable, and this one is one of those. We've got 2 of these V-shaped symbols, and all the rest are numerals that we've already deciphered. So we can algebraically figure out that V must be 7. And that makes sense because there are 3 of them. So it had to be one of those digits where there's only 3. So this V-shaped symbol is the numeral 7. I'll just mark that down on my chart and then square and replace the V-shaped symbols with 7s and see where else I can find something that I could puzzle through in one of these rows or columns. I see there's 2 more symbols that have 3 each. This upside down V-shaped symbol and this symbol that looks like a 9. Now we could just assume that that's a 9, but let's actually puzzle it up because we have this column that adds up to 111 with only 2 of these symbols in it and nothing else to get in our way. So again, we can use algebra to figure out, well, there's a 9, there's a symbol in the ones place in 2 places here. This is in the ones place and this is in the ones place. So it's 2 of those 9 symbols plus all the other bits that we have in the column add up to 111. And again, so we get 2 times 9 is 18, and that 9 symbol is indeed 9, which means that the other symbol, this upside down V shape, must be 8. Let's go ahead and replace those symbols both in our and on our drawing of the magic square and continue our hunt. Again, looking through, we find a row that has only one variable that's unknown, and we algebraically figure out that in fact that must be the 6th numeral. So let's put that in our chart and also in our magic square and move on. Again, scanning the rows and columns, we find a column that has only one variable in it. We can do the calc d equal 4, so we'll replace the 4's, and the only numeral left is this upside down b, which must be the 5, and we will replace the upside down b's. Now we have deciphered all of those Arabic numerals and written them in the form that we recognize as the Hindu Arabic numeral system. Looking back at the Wikipedia image that we found, we can see that in fact these numerals used thousands of years ago or more are in fact the same as these numerals, with slight variations in the 4 numeral and 5 numeral. So there you have it, the magic square written in Arabic numerals found at the base of a palace, a 13th century prince in Xian, China. Can be rewritten in our more modern version of the Hindu Arabic number system, and in fact it works out. Every row and every column and the diagonals add up to 111. Now that I've solved one magic square, here's another one. This one came from a 16th century Persian Book of Wonders in the Egyptian National Library. But there's some problems with this magic square because there are some duplicates. If I look at these squares, or these squares, or these squares, they have the same sets of symbols. So I think the scribe made some mistakes. Can you fix it? If you get stuck or if you want to check it, send me an email.